Good morning, College Algebra. I'm moving into 5.5 here, getting toward the end of Chapter 5, and we're supposed to solve exponential and log equations. So I got several examples I want to work with. Here's a few, and then I got a couple more I want to add to this. But, you know, we already solved some equations a little bit in some of my previous videos, but they officially presented here. So, you know, if I'm trying to solve this equation, e to the 3x equals this 822. I got to get to that 3x. I want to undo the e function. You know, that's a base e. So I think I want to do a logarithm. A logarithm will undo this, but I want to do a logarithm with the correct base. So I want to do a logarithm that's base e. If this base is e, I want to do a logarithm base e, and that's well known. That's the natural logarithm. So I take the natural log of both sides of this equation. I take the natural log of both sides of this equation. I don't pick up my calculator yet. What happens is the natural log cancels out the e. They're inverses of each other, and it leaves me this 3x, and it's down on this line now. So they cancel each other out, and now I have the natural log of 822. Of course, to solve for x, you divide by 3, and so x is the natural log of 822 divided by 3. So there's the answer. You do not divide the 3 into the 822. You don't do that. You do the natural log first, then you divide by 3. So there is a calculator version of this answer, a decimal version of this answer. I'll just try it. If I pick up my calculator and my glasses, I can maybe see this. There's my natural log button. I can do the natural log of 822. I can hit enter, and then I can divide by 3. And I'm getting a little 2.2372. I think I noticed our homework says round to 4 decimals. Maybe sometimes I might have said round to 3 decimals. It depends what the directions say. But there's the pure exact answer. But if I round it off, there it is. But the theme is, if you're trying to undo the e function, let's use a natural log. If it's base e. Now look at the next exponential equation. Here's another exponential equation. It's not base e, it's base 10. Well, then maybe I should use a log base 10 to undo the base 10. So I will do that. That's very famous log base 10. I don't really even have to write the little 10. Log base 10. I'll put a little subscript 10 here. Log base 10 of 10 to the x. And then I do the log base 10 of the 7, 6, 21. The log base 10 of the 10 cancels it out. It's the inverse of it, leaving me the x. And now I'm finished. And that's log base 10 of 7,621. That's the answer. You know, when it is log base 10, we've said you don't have to write the little subscript 10. If it's log base 3, log base 2, you usually write that little subscript. But anyway, there's the answer. I could punch that in the calculator. It's a different button. It's not the LN button. It's the LOG button. But I can type in the LOG of 7621. And I get another decimal. 3.8820 if I round to 4 decimal places. There's a train coming. Try to ignore it. So now I got, don't worry, it won't hit us. Now look at this. This is base 4. All right, so if it's base e, I've got a famous logarithm that'll help me, natural log. If it's base 10, I've got a famous log that'll help me, log base 10. The common log, they call that. But when it's base 4, I guess if I stick with this theme, I could use log base 4. I don't like log base 4 because there's not a button on my calculator. Although some of these modern calculators do have a button for that. But I want to change my strategy. My strategy is I want to use a natural log or a common log. And it won't kill the base, but watch what happens. So if I do the natural log of both sides, I'll do the natural log of 4 to the x and the natural log of 79. So I'm solving this equation. Now the natural log won't kill the base. They won't cancel each other out like my previous examples. But I do have this property 3 of logarithms. We discussed the properties of logarithms, and property 3 says you can bring this down front. So now I have my variable x down in front of this natural log of 4 equals the natural log of 79. And the natural log of 4 is just a number. And if it's multiplied by x and you're doing algebra, you can divide and you can find x. So x is the natural log of 79 divided by the natural log of 4. So I had a little different strategy. Instead of trying to kill the base, I used property 3 of logarithms that allows you to bring this, once I introduce a log on both sides, I can bring this down front, and that allows me to solve for x. I'll punch this in a calculator. This takes a little bit of skill. There's a decimal there, and then there's a decimal there, so be careful how you type it in. Natural log of 79, close my parentheses, divided by the natural log of 4, close those parentheses, that should be it. I'm getting this answer. You can check yourself with your calculator. 1519 if I round it to 4 decimal places. You should be practicing using your calculator, finding your ln button, your log buttons, practice getting these answers if you want. Okay, I'm going to keep talking here. So I'm solving exponential equations. So famous base e, famous base 10, I got a strategy for those. Any other weird base, I got a little different strategy for that. Now, your book, I noticed your homework had a problem like this. 5 to the x equals 125. Well, so that's a number 5. You might want me to approach it like that, and I could approach it like that. But what's funny about a problem like this is that 125 happens to be 5 cubed. So watch out for those. Sometimes these are a little easier if you understand that that's a 5 cubed. Then 5 to the x equals 5 cubed simply means drop the base 5s. Guess what? That exponent has to equal that x. If they're both the same base, then that exponent has to equal that x. So guess what? X equals 3. I mean, we've found x. We found... there's a lot of different ways to talk. One way to talk is, if I rewrite this as a logarithm, the answer is the exponent x is the log base 5 of 125. That happens to be a 3. It's the exponent you put on 5 in order to get 125. Again, I feel like you can't punch this in your calculator. Here's another approach to it. I feel like you can't punch this in your calculator because you don't have a log base 5 button, but some of your calculators might. You could do that change of base formula I talked about. You can change it to an ln of 125 over an ln of 5. If you pick up your calculator and do these, that's a crazy decimal, that's a crazy decimal, but when you divide them, the answer is 3. So there's kind of a lot of approaches, a lot of little connections here. I hope you're seeing some connections. I'm solving exponential equations. Now, also in this section, I'm supposed to solve logarithm equations. Check these out. I'm switching gears here. You know, if I just have the ln of x equals 2, and you're supposed to solve for x, this one's really weird, but you simply rewrite the logarithm. That's the phrase I like to use. You rewrite the logarithm in exponential form. Now, that means you start with the base. Now, what's the base? When it's an ln, the base is e. There's a little subscript e that I don't have to write. So it's e raised to the power 2 equals this in here x. So e to the 2 equals x. So I'm finished. I just solved for x. What's x? E squared. What's e squared? I can find that on my calculator. I gotta find my e button, not my log button, my e button. E squared, according to my calculator, is 7.389. Technically 1 if I'm going to 4 decimal places. 7.3891. Here, let's try a little better one. Watch this one. Solve for x. I'm trying to solve for x. Log base 6 of 4x minus 3. Sorry. Equals 2. Solve for x. Well, so my theme has been rewrite the logarithm. Rewrite the logarithm. Okay. The base is 6. The exponent is the answer. The answer to the logarithm is the exponent. So 6 raised to the 2 equals what's inside the logarithm, 4x minus 3. Once you rewrite the logarithm, it's so easy. Now you got an old, look at this, 36 equals 4x minus 3. I mean, it's easy old algebra now. Add 3, you're trying to solve for x. Add 3, 39, divide by 4, there's your answer. All right, they get a little more complicated. Look at this one here. Look at this one here. Log base 2 of, I like that one a lot though. Log base 2 of x plus log base 2 of x plus 1 equals log base 2 of 2. I think I found one like this in the homework. Just got a couple more and then I'll quit. Yeah, this is tough, dude. I mean, I can't, wow. So what I really want to do is I'd like to get these logs together. Well, there's a property of logarithms that says you can add these, well, wait a minute. When you have 2 logs added together, you could write it as 1 log of these 2 things multiplied. So now I have an x times an x plus 1. And it equals this log base 2 over here. So now that it's 1 log base 2 equals this other log base 2. I can just cancel the logs on both sides. So I can cancel this log and cancel this log, and then this x plus 1 has to equal 2. And now I'm back to doing kind of old chapter 3 algebra actually. This is if I distribute this, it's a quadratic equation. X squared plus x, I should move the 2 over. If it's quadratic, I should get it equal to 0. I should factor. I think it factors, or I could do the quadratic formula. X plus 2, x minus 1 are the factors. Set each factor equal to 0. We get our answers. X equals to negative 2 comes from that. X equals 1. There you go. I got a couple answers. Now hold on. You're not allowed to take the log of a negative number. So maybe we should check these. If I check these and plug this negative 2 back in here, I'll have the log of a negative number. That's illegal. That answer doesn't work. I have to throw that answer away. So there's really only one answer. Let me check. If I plug in that 1, I can do the log of 1. I can do the log of, yeah, this is fine. This is my answer. All right. Combine your logs and maybe rewrite the logs and you can solve these equations. Thanks for listening. Do some homework.